Hello, Brandon Clayton, the Algebra Guy. Today I'm talking about how to add and subtract decimals. Very straightforward, right? So we are going to be in a situation where you add and subtract decimals. You've done it before in real life, and let's talk about how to formally do it here in this program. So how do we add and subtract decimals? That's the first question we're going to answer. How do we handle the decimals when we do finish adding them, and how do we subtract numbers that yield a negative value? What if there's a negative value at the end? What do we do there? So let's again start with what we talked about in the previous lesson, where we're not unfamiliar with this idea, because if we bought a sandwich for $1.35 and a bottle of water for $1.25 and we had to pay tax for 33 cents, we would add all these up. 5 5 is 10, it's 13, 14, 15, 16, 17, 18, 19, and that'll be $3.93. So we know how to add fractions. We wouldn't move those decimals out the way. We'll be appalled if someone said that's going to be, let's say they moved the decimal here and made it $13, or moved the decimal here and made it $39. So we understand intuitively how to do that, and so we've been doing it. So this shouldn't be a huge surprise to you. However, let's go over the formal steps. Write the numbers vertically so that the decimal points are lined up like we just did. Use zeros as placeholder as you need to, and we'll talk about that. Sometimes you'll need to use a zero to kind of line everything up better. Add and subtract numbers as they were whole numbers, then place decimals in the answers under the decimal points in a given number. So let's practice that. So in order to practice that, we're going to do what I just said. So we're going to line them up. 12.4. Actually, you know what? I'm going to put it the same order they have it, just so we can make the point about making sure they line up. So we got 12.4. I'm sorry, 3.7 plus 12.4. And we're going to add these up straight as they are. Now, if you want to put a zero here, you can. It's not going to change that value. It's not common to do that, but you could just visually do that. 7 plus 4 is going to give us 11. 3 plus 2 is 5, plus 1 is 6. And then there's just 1 there. And I'm just going to bring this decimal straight down here to give me my final answer of 16.1. And that's how you do it. Pretty simple. And it would have been the same if we put our 12 on the top. That won't change our answer at all. You can imagine what that looks like in your head. I'm not going to work it out, but it's still going to give us the same value. All right, let's try another one. What if you had 5.7? And honestly, I'm going to do it the way I would normally do it. I wouldn't write this. I'll write the bigger number on top since we're adding, and we know that adding either way, whichever goes first, is going to be the same answer. So I just feel more comfortable adding the bigger number on top. So that's 5.7. Now I just add straight up and down. 9 plus 7 is 6. 5, 1 is 6 plus 7. 1, bring my decimal straight down, and there we are. Pretty easy. All right, so we got a slightly bigger number, 4138. Since I'm adding, I just went ahead and put my bigger number on top just because I know it's going to be the same answer. 23.5. All right, so look at what happens in this situation. When we want to add, there's nothing right here. What should we do? So we're going to put a place value of just 0 here because, again, we talked about this. It's an equivalent decimal. It does not change the value here, but it just allows us to visually have something that's continuous and it just looks good to our eyes. So 8 plus 0 is 8. 5 plus 3 is 8. Bring down our decimals. 3 plus 1 is 4. 2 plus 4 is 6. And there you go. Voila. All right, what if you were in this situation and you had a $20 bill and wanted change, and you bought something for $14.65? So how do you deal with this? What's going to be your answer? So you'll do the same thing. $20. Where is the decimal here? Well, the decimal is always understood to be at the end, even if it's not written. And we got minus 14.65. Now, in subtraction, I do want to make sure I keep the first number, the first term first. But we'll talk about that more in a second. So for here, I'm going to put placeholders so I can easily subtract. You know, you can do your 1 here, your 9, 9, and 10, 3, 5, so 535. Now, I'll be honest with you, I don't do this anymore. It's so much easier to add, and I'm going to show you that real quick. If I knew that, if I wanted the difference between 20 and 1465, I'm really going to just add in my head. I'm going to say, how much more do I need to add to 1465 to get to 20? So I'm going to add 35 cents here to get me to the closest dollar. So adding 35 cents to 1465 gets me to $15. So what did I add so far? All I added was 35 cents. Well, to get to $20, I need to add another 5. And that'll get me to that $20. So now, what have I added is 5 and 35. So that'll be 535 as a total. All right, and here's another one similar to that. You got a 50 and you bought dinner for you and your family or whoever you're with, and it was $37. What is the change you should expect back? Expect a decimal there. And this is 42. And you can put your zeros here. Again, I prefer not to go and do the 4, 9, 9, 10. I prefer to just add, because you can easily add in your head, and I'm going to do that now. So if I added, how much I need to add to 42 cents to get to the nearest dollar? Well, I know I at least need to add 58 cents. Well, adding 58 cents takes me to $38 from 42. It takes me up to $38. How much I need to get from $38 to 50? Well, I can add $12 more dollars, so adding $12. So I know that's going to be a total of $12.58 that I added. So that's the difference between these two. Now I'm going to go ahead and finish working it here just to show you that it does work out. 10 minus 2 is 8. 9 minus 4 is 5. 9 minus 7 is 2. And 4 minus 3 is 1. There it is. But this is nice to do it this way because it's hard to do this in your head. But this way you can kind of intuitively think about it if you're at a cash register or trying to do the numbers. Just add versus subtracting. Our brain works so much better adding than it does subtracting. What about this one right here, 2 minus 7? So 2 minus 7 is going to give us a negative number. So how do we handle that? Well, what you're going to do in this situation is just remember that the distance between 2.51 and 7.5 is going to be the same number, but you're going to have a negative value. So what do I mean is, if I were to draw a number line, and we did let's say this is 0, and this is 2.51, and we subtracted 7.4. So we subtracted 7.4. It's going to be somewhere over here because we took away 7.4. Now, we know that distance between 2.51 and taking away 7.4, it's going to stay the same no matter what. So if I said 7.4 minus 2.51, it's still going to give me the same answer. I just need to remember that the answer is going to be negative because it's not actually 7.4 minus 2.1, it's 2.51 minus 7.4, which is going to give me a negative answer. So you just got to remember that, switch those, and then subtract. I'm going to put a 0 there as a placeholder, and now start to subtract. So I believe that's going to be 3, 10, 9, 6, 13, 8, 9, 10, 11, 12, 13 is 8, and that's a 4. So it looks like that's 489. Is that right? I don't like to subtract, but it looks like that looks good. So there's going to be a difference, a negative 489, 4.89. I need to write that more clearly. Negative 4.89. I'm on this one. Is the difference here. And the same thing here. You'll remember that 4 minus a 6 is going to give you a negative. So we'll just go ahead and subtract 4.77. And notice I put a 0 at the end because I knew I was going to get another number here to make it easy to visualize. To remember that I have a negative, I'm going to go ahead and write it negative here because I know that 4 minus a 6 is actually going to give me a negative because you can't take 6 out of 4 and without going below 0. So now we start to subtract. We take out, we make that 2, 10, 3, 5, 12. That's going to be 5, and this is 1. So negative 1.53 is my difference. Trick 5. I just kind of like to always, it's always good to just eyeball and double check your work for small errors. So that's what I'm doing now. I'm asking myself, does 4.77 plus 1.53 give me 6.3? So I'm working backwards to see if it's actually going to give me the answer, and it does. All right, so we did it all. How do we add and subtract decimals? We talked about how to do that. Keep the decimals lined up and just add straight up and down vertically. How do we handle those decimals? Well, just keep them in the same order. And how do you subtract numbers that yield a negative sign? Make sure you just put the bigger number first, the larger looking number, I would say, and to keep your negative sign when you know those numbers are going to be negative. Thank you for tuning in. My name is Brandon Clayton, the Algebra Guy, and thank you. I'll see you next lesson.